Hey friends, have you ever wanted to send a scrambled message to someone and have them try to decipher it on their own using mathematics? Well, we can do that, and this is another neat application of matrices and determinants. So today we're going to learn about cryptography. Cryptography is basically just how do you send a cryptogram or an encoded message using an inverse. What we're going to have to do is we're going to have to assign numbers to our secret message, plug them into a matrix, and scramble it. And then hopefully our friend will be able to unscramble it using a different matrix. Now, the notes here on these pages will deal with 3x3 matrices, but I want to do 2x2s instead to make it a little bit easier. So here is our helpful key, where every letter in the English alphabet is assigned a number. And if there's a space in our message, we can just use the number 0 for that. So why don't we do the first thing called encoding? And encoding is to actually scramble the message. Let's make our normal message, put it into numbers, and then we'll scramble it or encode it. Well, the first thing you want to do is let's just find a fun message like Happy Friday. All right. So first of all, let's take Happy Friday, and can we turn every letter in Happy Friday into a number? Let's use the alphabet reference that we have up here. Ready? H is 8. A is 1, P is 16, so P, Y is 25, and there's a space, so remember the space is 0. F is 6, R is 18, the letter I is 9, D is 4, A is 1, and Y is 25. So the first step is after you come up with a really clever message, scramble it. Before we scramble it, let's transfer all the letters in your message into numbers using the alphabet. And remember, any spaces become a 0. If there is a space at the end, we'll need to put a 0 in, and we might see that a little bit later. So now, the instructions here say turn them into 1x3 row matrices, but we're actually going to turn them into 1x2 because we want to do 2x2 matrices, not the tough 3x3s. So what I mean is, let's turn every two numbers into a 1x2, 1x2, 1 row, 2 column matrices. Now, like I said, if by chance you have an odd number and you have something left over here, you're going to have to add a 0 here or a space at the end of your message because you need an even number of numbers inside your matrix. You have to have 1x2s. You can't have a 1x1 by itself. So if you have a leftover letter, go ahead and include a space at the end and we'll put a 0 in. All right, I've got 1, 2, 3, 4, 5, 6 1x2s. What we're going to do is going to feed each one of those into a 2x2 encoding matrix. Here's a 3x3 one, but I'm going to eliminate all these extra numbers here. I'm going to cheat and turn it into a 2x2. So can we call this one A? 1, -2, -1, and 1. So now what we're going to do is we're going to feed each one of these 1x2 matrices into our encoding or scrambling matrix, almost like when you feed a dollar bill into a vending machine. You feed in the dollar bill and out pops out your soda or snack. Well, for us, out is going to pop out the scrambled matrix that we're going to put together. All right, so each 1x2 matrix is going to be multiplied into our encoding. And notice the order in which we do it. In order for this to be legal, we need to multiply the 1x2 on the left and the scrambling or encoding matrix on the right. It wouldn't work the other way because this is a 1x2 and a 2x2. All right, ready? Rows by columns. And when I scramble 8, 1, row by column, I should get another 1x2, and it would be 7, I think, and -15. So 8 and 1 just got scrambled into 7 and -15 just by doing matrix multiplication. Notice that the numbers that come out can't refer to another letter because that's a negative. So we know we scrambled it really well. Anyone who's going to decipher this and pick it up will have no idea what it means because there are negative numbers. Strange. Next one. Let's go ahead and take the next 1x2 matrix, which was 16, 16, and we're going to feed that into our same scrambling and coding matrix. And again, if I do it in this direction, it's legal. I should get a 1x2 matrix back out. Ready? Multiply rows by columns. I should get 0 and negative 16. All right. And we keep going and keep going. Why don't you take the next 4 1 by 2 matrices, feed them into our A scrambling and coding matrix, and see what you get, and we'll double check all our answers. Okay, friends, here we go. Let me keep going. And the next one I got was 25, 0 is going to feed into my scrambling matrix, which was 1, neg 2, and 1. And each time we do this, we might get a different scrambling matrix depending on the message. But for now, this is the same scrambling matrix we're going to use for this example. All right. I should get a 1 by 2 out, and I should get, did you get 25, comma, negative 50? There we go. Let's scramble the 618. I'll do it over here. 618 into our scrambling matrix. Again, that order is legal. I should get another 1 by 2 out, and that should be negative 12 and 6. All right. How about we do 9 and 4? Let's scramble 9, 4 into our scrambling matrix. I should get another 1 by 2 out, and I should get 5 and I think negative 14, if I got that right. And then the last one, 125. When you scramble 125 into our scrambling matrix, friends, I should get, how about another 1 by 2, should be negative 24 and 23. All right, check all your answers and see if that worked. So now what we do is we're going to take our new numbers we got and give that to our partner who's going to try to decipher what that is. So this message that I put here, Happy Friday, was turned into this. And once I scramble or encode it, the new message looks just like this. 8, 1 turned into 7, neg 15. The 16, 16 turned into 0, negative 16. The 25, 0 turned into 25, negative 50. The 618 turned into negative 12, 6. 9, 4 turned into, and 125 turned into negative 24, 23. There is your brand new message that you would send to someone. And they tried to attach letters to it, they'd have a really hard time because there's a lot of negatives, and we can't do that. So there's your scrambled message. If it's intercepted by an enemy, they would have no idea what to do. So we're going to send it to our friend and see if they can scramble it back. Now, if we used an A matrix to scramble or encode it, what do you think we're going to use to decode or unscramble it back? Did you guess the inverse? Good for you. That's what we're going to do. So we need to find A inverse first. Find the inverse of our scrambling matrix that we just used, and then we're going to feed our scrambled matrix just directly into our inverse matrix, and out should pop out the original. So we're going to take every 1 by 2 of our scrambled matrix and feed it into our A inverse, and out should pop out the answer. Okay, so first thing we should do is probably find A inverse. Do you remember what A was? I think A was 1, negative 1, negative 2, and 1. Let me just double check so I don't have that wrong. Okay, so if that's A, let's go ahead and find A inverse. Why don't we do the determinant first? Determinant of A, down right minus down left, should be 1 minus 2 or negative 1. That means A inverse should be 1 over the determinant times our scrambling of the original A, where the top left and the bottom right changed. Nothing much happened. And the top right and bottom left just changed signs. All right. So if I multiply in by the negative 1 in front, my A inverse is neg 1, neg 2, neg 1, and neg 1. All right, guys. So that's our new sort of vending machine. We're going to feed in all of the scrambled numbers that we just got from our friend into this matrix, and out should pop out all the answers. So let me start you with the first one, and can you figure out the rest? You know what the answer is. We should get Happy Friday back out, but let's see if it works. All right, I need some room over here. I'm going to take my A inverse, which was, again, all neg1s except that neg2 on top. And we're going to take the scrambled matrix we made right up here and feed them. Now, in order to feed them, we have to put them back into little 1x2s, right? Just like we did in the first step. All right, so why don't we feed each one of those one at a time into our inverse, and I bet you out will pop out the original. The first one was 7, -15. All right, why don't we do this one together to see if it works, and then you can do the rest to double check that it really, really does work. Okay, this is a 1x2 and a 2x2. It should work. I should get 8. And when I multiply that one, rows by columns, I get -14 plus 15, which is 1. All right, why don't you go ahead and go back. Let's take all the other ones we found and plug them into our inverse, and you'll just see how cool it works. And if it does work, we should get Happy Friday back out. Go for it. Try it on your own, and we'll come back and double check them. I'm going to set everything up first, and then I'll go ahead and multiply at the end. 25 -50 with our inverse. So we plug in the scrambled message into our inverse, and it should unscramble it back into the original. -12/6 into our inverse. Five -14. It was said that way back in World War II, this was a very, very popular way of scrambling messages among the Allies using matrices. Wish Mr. Brown was there. I could be doing this for them in my head. We did 5 -14, then we have -24/23. Feed it into my inverse. Now, I think I should have, how many, did I say 6 of them? I should have 6. Can we double check? 1, 2, 3, 4, 5, 6. Great. All right, here we go. Rows by columns, everybody. I should get here 16 and 16. Doing the multiplication really fast. I should get 25 and I think 0 here. Great. And then more on this one here, rows by columns. I should get 12 minus 6, which is 6. 24 minus 6 is 18. And finally down here, rows by columns. How about -5 plus 14 and -10 plus 14. -10 plus 14. I think that's right. I don't remember that being a y. We're going to check and see what happened. Hold on just a sec. All right. So now we're going to go back to our... Oh, you know what happened? I think... Oh, I didn't do the last one. Mr. Brown. All right. Rows by columns. 24 minus that should be there. And then finally, how about positive 48 minus 23? I think that's 25. Okay. Now we're going to go back to our reference of all the letters of the alphabet up here on the top. And take all our numbers and turn them back into letters. Ready? Here we go. So 8-1, the 8th letter was H. The first letter is A. 16 was P, I remember. 25 is Y. And then 0 is just a space. 6 is an F. 18 is an R. 9th letter is an I, the 4th is a D. And would you look at that? So once you put that all together, your final message that you got from your friend after you fully unscrambled it using the inverse matrix was this. And that's how we do cryptography. Great job, everybody.